All right, I'm probably going to do the next two pages, pages 8 and 9 in this one, but I wanted to do this one separately from the last video, in large part because this one talks about the periodic table, and I want to make sure that we're all getting the right things or the same things for that. So the first thing it tells you to do is practice labeling your periodic table, and label each column with the number of valence electrons that the column will have, and label each column with a likely charge that the atom would have in that column. So in the first column, all of those elements have one valence electron. Okay. And then in the second column, all of these atoms have two valence electrons. And then we're going to skip the transition metals, so columns 3 through 12 in terms of valence electrons. And we're going to jump into the 15th column, which has 3 valence electrons. The 14th column has 4 valence electrons. The 15th column has 5 valence electrons. The 16th column has 6 valence electrons. 17th column has 7 valence electrons. And the 18th column has 8 valence electrons. The 18th column has 8 valence electrons, and it is a full energy level, or something that we call a full octet. That one is generally considered the most inert or non-reactive. That column is made up of elements that are the most inert or non-reactive. Now, if you are an element that has one valence electron, the likelihood of you losing an electron is pretty high. So hydrogen and lithium and sodium and potassium and rubidium will lose an electron and become a charge of +1. Beryllium, magnesium, calcium, strontium, they have 2 valence electrons. They're likely to lose those 2 electrons to become a +2. Again, we're going to skip the elements in the middle, transition metals, and then we're going to jump over to boron and aluminum and gallium. Those have 3 valence electrons, and they're likely going to lose 3 electrons, so they're going to be a +3. We're going to skip over the carbon column because some weird things can kind of happen there. So we're just going to jump over right to column 15, which has 5 valence electrons. And because it has more than half, sometimes it's easier to look at it being easier to gain electrons than it is to lose electrons. So in this case, it's going to gain 3 electrons for a charge of -3. Oxygen will gain 2 electrons. Oxygen's column will gain 2 electrons to become a charge of -2. And then the 17th column, the halogens, will gain 1 electron to become a charge of -1. And then again, the last column, they tend to have no charge because they are inert, or they have more electrons, or they have enough electrons in their outermost energy level, so they won't gain or lose. Now we're going to use the information up above to help us fill in the chart below here. So I'm going to locate bromine. And bromine right here is in the 17th column. So bromine is going to have 7 valence electrons, and its charge is going to be -1, because I have that information right up above. Calcium is over here. It's in the second column. It has 2 valence electrons, and it will lose those 2 electrons to get a charge of +2. And then aluminum. Aluminum is in the 13th column. It has 3 valence electrons. It's going to likely gain lose 3 electrons. I misspoke. So it has 3 valence electrons, and it will likely gain or lose 3 electrons to get a +3. Continuing on to the next side here, so this would be page 9, we're going to use the information on the periodic table to help us figure out some stuff about where elements are located on the periodic table in relation to ionic and covalent bonds. So metals are generally located to the left and below the staircase, or the metalloid line. Nonmetals are located to the right and above. The stair-step line, with the one exception of hydrogen, which is a nonmetal on the left side, and hydrogen is kind of special. It does whatever it wants. Now, you know an ionic bond will occur when you have a metal in the compound, when a metal is present. Okay, so if you're asked to identify the type of bond that's present based on the types of elements that you're given, in the case of HCl, I'm going to say that that's going to be a covalent bond. And how do I know that? Well, I know that hydrogen is a nonmetal, and I know that chlorine is a nonmetal. Hydrogen's in column 1, which is the weird one, but chlorine is in column 17, so it's definitely on the nonmetal side. In the case of FeCl3, I'm going to know that that is ionic because iron is a metal and chlorine is a nonmetal. And in the case of NO3, I'm going to identify that to be covalent because nitrogen is a nonmetal and oxygen is also a nonmetal. So you could also write things like, for an ionic bond, a metal is present. You could also write for covalent bonds that no metal is present. I think that those basically say the same thing as what I wrote. All right, now drawing Lewis structures. There is sort of a pattern for drawing Lewis structures, at least that's the way that I was taught, so it's the way that I teach it. If E is going to be my elemental symbol, the way that I usually draw them would be start on the top and go 1, 2, 3, 4, and then go back and double up 5, 6, 7, 8. That doesn't necessarily mean it's the only way, but it's the way that I was taught, so it's the way that I'm going to show them here. So I'm telling you that selenium has 6 valence electrons. And so selenium will be my element in the middle, and the 6 valence electrons, I'm going to draw 1, 2, 3, 4, 5, 6. Argon has 8 valence electrons, and so I'm going to draw the same thing in the same pattern. 1, 2, 3, 4, double up, 5, 6, 7, 8. And then gallium, which is a metal, has 3 valence electrons, and so I'm going to do the same thing. 1, 2, 3. Again, if your teacher showed you a slightly different way to draw the Lewis dot structure, go with that. But this is the way that I was taught. It's what I taught my kids. So again, if you have any questions about this, about either the periodic table, valence electrons, charges of ions, or whether a bond is ionic or covalent, or drawing Lewis dot structures, make sure you touch base with your teacher. Otherwise, good luck studying for exams, and have a good afternoon.